We will move on to the next speaker.
Thank you.
So we have had a schedule change, so we've switched up some things because the next speaker is actually a little bit delayed. So instead of Professor Javier Sanchez Yamagishi, I would like to welcome Professor Ivan Deutsch, a Regents Professor at the University of New Mexico and Director of the Center of Quantum Information and Control. So this center is an NSF-focused research hub in theoretical physics, and it's a participant in an NSF Quantum Leap Challenges Institute that's led by CU Boulder. It's also a participant in a quantum systems accelerator and the administrative home of the Southwest Quantum Information and Technology Institute. Okay, so you have about 15 minutes with 5 minutes for questions.
Thank you, Serena, and thanks to all the organizers for putting together this important workshop. I assume everyone sees my slides and can hear me okay.
Yes.
Very good, right. So again, my name is Ivan Deutsch and I'm here in Albuquerque, New Mexico. This is our little skyline. If you didn't know, we're also the Mile High City out here in Albuquerque. And I'm the director for the Center for Quantum Information and Control, which we call CQUIC, rhymes with Bisquick. So just so you know. All right. So our center and the work that we do at UNM, it really focuses around quantum information science. And quantum information science is an interdisciplinary field that really draws from a variety of traditional disciplines in physics and computer science, engineering, math, chemistry. And this is a nice website you can go to at NIST. I'm also was a NISTer, like Corey. I was a postdoc at NIST many years ago, and really talks about the interdisciplinary nature of the field. And that's part of the theme I'm going to talk to you all about today, the importance of interdisciplinarity to make success of your program. And here are some of the what we like to call the pillars of quantum information science: quantum computing, quantum communications, and quantum sensing metrology. We just heard from Professor Patti about the Quantum Sensing Center, but of course, these are some of the other pillars. And, you know, we've been talking a lot so far about industry and how this quantum workforce is important for private industry, but I also want to emphasize it's important for knowledge, that quantum information science informs fundamental science, which is at the foundation of what we're doing here. And we learn about things like the complexity of matter and quantum gravity and chemical processes by learning about quantum information science. So we shouldn't lose sight that we're not just producing workers for factories, we're also producing knowledge. All right. Now, I come from a little bit of a different side, I think, than many here. We at the University of New Mexico have a very long history in this area. Really going back to my colleague, Carl Caves, who started at UNM, what was then called the Information Physics Group in 1992, probably before some of you were born. Carl is famous, amongst many things, for developing the idea of putting squeeze states into gravity wave detection in his PhD thesis, and he's a pioneer in the field. And we at UNM, I joined UNM in 1995 to work with Carl to develop a new program in quantum information science, and our center was established in 2009. So we are a center which has 7 core faculty, 15 associate faculty, well, now we have more, actually. This is out of date. We have 6 postdocs and around 25 students. And our mission is really about interdisciplinarity and bringing together all the different fields. That's been the important frontier for us in recent years. We started in the physics department, but we have expanded across College of Engineering and the College of Arts and Sciences, working in a variety of focus areas. So that's really our frontier right now. Let's see if I can get this thing to change. There we go. And we live in a fairly rich environment. One of the things that we're lucky about in New Mexico is our national laboratory environment. Sandia and Los Alamos National Labs are nearby by Southwest standards. We partner with them in developing these programs, in addition to other centers that are more well-established and long-term at the University of New Mexico, the Center for High Technology Materials and the Center for Advanced Computing Research. So that's another thing I think I'll talk about in the tips, is thinking about your local environment and how you can leverage what resources, intellectual infrastructure resources are in your environment to help build your program locally. So I mentioned we have these partners. They're partners in Sandia, Los Alamos. Also, we work closely next door with the University of Arizona and others within the University of New Mexico. We have, as I say, a fairly big postdoctoral program. The question of international versus domestic, I was actually just looking, these are our current postdocs. Philip is from Denmark. Sula, they're American. They're from Oregon. June is from Japan. Lou is from China, and Marco is from Mexico, the old Mexico. And so we have, but diversity is important, and we're not doing as good a job as we need to in many areas, but that's an important aspect of building the workforce. And here's sort of a snapshot of our students from all walks of life, and diversity is something that we really care about. All right, let me say a few words about what we do in the way of education and degrees in our program. As I say, the challenge is interdisciplinarity in teaching and developing degrees and courses that bring together the traditional disciplines with what I like to call the transdisciplinary aspects of quantum. And so what we're doing currently is we're right now working at the graduate level. And we have developed a concentration in quantum information science that can be added to traditional degrees. So it can be added as a concentration on top of physics, or on top of electrical engineering, or on top of chemistry. So we don't have to have we don't have to go to the higher education department to get a new degree, right? Or it's easier for us to add a concentration on top of an existing degree. And the way we bring that together is that we have a primary course, which is a kind of unifier for all of the programs, Foundations of Quantum Information Science, which alternates amongst the different departments that teach that. And to a question that was asked, Serena, earlier about teaching release, yes, we build that in, to some of the big grants that we have, that there is buyouts so that faculty have the time that's necessary to develop new curricula, which is critical. We just can't ask people just to do more when people don't have any time to do what they're already doing. And we have, of course, a long history. And so we have been teaching many of these courses for a long time. These are graduate courses, and teaching this course in quantum optics for a decade or more. One thing, a tip, I put all my lectures online and my videos of my lectures. I get emails from kids in Bangladesh saying, when are you going to put the solutions to problem set 7 on? And that's one of the most, I find, really rewarding things, that we have the opportunity to share and educate the world in the modern world as well. Let me say a little bit about our center-wide research funding, again, we're a little bit different than I think many of the programs here. We've been at this for a very long time, and we have a longer track record. But just to give you a sense of who we are, as was mentioned, we are, we just got renewed, hooray, for our Focus Research Hub in theoretical physics. This is funding from the National Science Foundation that has key goals to both advance cutting-edge research and advance early career scientists. And we do that primarily through a prize postdoctoral fellowship program, as well as being a hub for hot topics workshops, and for also our famed Squint annual workshop. We're part of, Corey mentioned the panoply of new centers that have been stood up under the National Quantum Initiative. One of them is a DOE center called Quantum Systems Accelerator. This is led out of Lawrence Berkeley Laboratories and Sandia National Laboratories. And we at CQUIC are part of this center, as well as the NSF Quantum Leap Challenge Institute, which is known as QSense. This focuses on quantum sensing, and the lead institution on this is the University of Colorado in Boulder, and many of our faculty are involved in this center as well. In terms of outreach, I mentioned Squint. Actually, the School of Mines has been a participant in Squint for years, and we are a kind of consortium of 29 node institutions of the Squint network, and we really emphasize community. And we've been around for 25 years, so we have Squint kids and Squint grandkids, so to speak, students who grew up in Squint who now have their own students, and their students have students, and it's quite fun for me to see this. But it's important because we really try to emphasize this is not just a student conference. This is an opportunity at which young early career scientists have the chance to give talks and presentations at the same time as Nobel laureates. Sergio Roche and Bill Phillips have given talks at Squint at the same time as postdocs. But building that community is critical. We in New Mexico are, of course, a majority minority state, and so it's critical for us to reach out to the talent, the diverse talent that exists within our state. And one of the ways we do that is through the Q-Reach program that really targets underrepresented groups, women, minorities, first generation college students, etc., to have opportunities to come to our university to have hands-on experience. This is a new program led by Victor Costa, one of my colleagues, professor in physics and astronomy. I just say a couple of things. We're trying to really build, again, I mentioned regionalism. I think is important to think about your region. New Mexico is a quantum state. That's our tagline. And we're not both alive and dead at the same time. We are working on the quantum workforce. And we just had a symposium. Actually, Corey attended that symposium, and we thank Corey for his input to try to build both the broad, to expand to our tribal colleges, to our community colleges, to some of our other institutions, and build a joint institute between the University of New Mexico and Sandia. So that's really where I'm spending all my time these days, trying to stand up QNM. Okay, I'll just conclude then with some of my thoughts about, what are the hurdles and tips that, and I'm happy to discuss this more in the Q&A. So again, I emphasize this issue of interdisciplinarity. Quantum information science is intrinsically an interdisciplinary subject, and collaborative, but departments are disciplinary and pretty tribal. And it's very hard to break down those walls. And I think one really has to work hard to see how one can do that, especially for things like degrees and courses. How do you cross-list? How do you work together to build interdisciplinary education? So, you know, it's nothing is for free. And if you're going to develop new curriculum degrees, it's going to come at the expense of something else. You're going to teach a new course, maybe you have to give up an old course. So you have to think about what it is you're going to sacrifice. How are you going to change? How are you going to move on? How are you going to build something? There are always compromises, and what compromises are you going to make? You know, again, there's kind of a chicken and egg problem. I see it as a hurdle. To get things going, you need investment. You need investment of time and you need investment of money, but there's risk involved in that. And how you balance that, what comes first to get your program off the ground. So what are my tips? I think the very first important thing is you really need to have solid science and engineering foundation. That really needs to be the foundation upon which your program is built. I want to mention interdisciplinarity. This seeks commitment. You know, it's hard. I was trained in atomic physics and optical physics. I knew nothing about information science, but it took time to learn things. And so that commitment is necessary to really move forward. And then finally, I just say, you know, think about your regional strength. For example, you know, in Colorado, there's the CU Qubit program, and think about the diversity in your state and how you build your strength through that diversity. So I'll stop there and take questions, and thank you very much.
Okay, thank you very much. Let's thank Professor Deutsch for his presentation. The longevity of your center is very admirable. Congrats on your recent renewal of your NSF Focus Research Hub. That's great. And let's open up the session for questions. We'll start with Professor Providence. Actually, feel free to ask your questions. You don't have to. We're a small enough group that you can just chime right in.
To listen.
Yes.
Oh, yes. I think your second or third slide, it had something to do with, you were showing curricula for different disciplines, different departments. I just noticed it kind of jumped out at me that the math program didn't list linear algebra, abstract algebra, and I was thinking maybe that's just an oversight.
Yeah, it's an oversight, absolutely. I think that's critical, obviously. Linear algebra is such an important part of the mathematical structure of quantum mechanics. So yeah, that I will let's make sure that I put that in over here. All right, I'm listening. Other questions?
Yes, Thomas, feel free to ask a question.
Yes, do you have any advice for convincing administrators, university administrators, that quantum is important?
Yeah, I think there's, you know, this is kind of the chicken and egg problem that I was mentioning. I think we, in some sense, you could say got lucky, or it just was the turn of events that we were working on this area before it became an area of national prominence. And so we had a bit of a track record of existing funding in this area that we could go to our administration to say, you know, build on this. And the returns will be great for the university. It's important for the university. So, I mean, obviously, you know, right now one can point to the variety of initiatives that are happening across the country, both in terms of, you know, the federal support that we see for programs like the Expand QISC that was mentioned in the NSF, and of course a variety of existing programs in the Quantum Leap program in NSF and DoD and DOE. But I think it's important also for individual investigators to work to try to build their own portfolio too, proposing for individual grants, because I think the combination of the incentive from the top together with the grassroots from the bottom, I think is the best recipe for success.
Okay, thank you. Other questions? Feel free to jump right in and ask.
May I ask another
also.
question? This is Professor Providence again. That same slide, you mentioned density functional theory. Could you expand on that? Because that happens to be some interest of ours.
Yeah, so one of my colleagues, Susan Atlas, she is that is her traditional area of expertise, functional theory, but she's interested in now trying to understand how one might use quantum computers to make algorithms to study in a platform native way that takes advantage of some of the entanglement that exists in quantum computers as a way of simulating density functional theory. So bringing traditional areas of chemistry like electronic structure theory, decimal functional theory, and what quantum information science, how it can inform us, is another example of that kind of interdisciplinarity.
Okay, thank you. I think we also have a question from Tara.
Hi.
Hi.
Sorry, I'm curious if you have any advice on how to efficiently build capacity in QIS. What's
in
most
terms
important?
of the faculty or students or both?
Well, that's the question, is what's most important? Is it,
Yeah.
having the faculty? Is it having the actual, hardware type infrastructure? Is it about having the students? What makes an institute like this fly?
Yeah, so it's a good question. So here's a place, as you may have noticed, we're much more heavily a theory centered than a center does. We do have experimental laboratory science engineering, but in my department, I'm a physicist. I'm in the Department of Physics and Astronomy. We only have one, I would say, real quantum information science lab, and some, I would say, quantum adjacent. They're doing quantum, but not really central part of our center. And this is, I think, a real problem. And the problem is, in the same way that there is income inequality at the personal level, there is institutional income inequality. And right now, to the startup packages that are necessary to attract experimental laboratories are, upwards of $1 million. And, the University of Mexico cannot afford that. It's hard for us to do that. And so we've built around theory, but I think we shortchange our students in that way because, I think we need a diversity also of experience and opportunities, both in theoretical and experimental quantum information science. So, the capacity building will be dependent to some degree on your institutional abilities. I do think the faculty are critical. I think you need the faculty in order to attract the students. The students come because of the faculty they have the opportunity to work with. And I think as we look as a nation to try to build this capacity, this question of how we're going to make the investments, how are we going to make sure that students around the country can, for example, get the hands-on laboratory experiences, not just by going to a few elite institutions, but going around the country to state and institutions like myself. Where I am. So I think capacity is an important question. And I think, I applaud the NSF for the Expand QISE program as an example, but, having seed funding for startup will be an important aspect. What we do as a nation to invest is still, I think we're trying to answer that question.
You had also mentioned leveraging, your local resources. And I used to work at Sandia National Labs. And I remember that UNM had students that were over working in CENT and getting hands-on experience with low temperature measurement of these silicon-based qubits, as well as the clean room that's right over there. That's very close to your location.
Absolutely. We've really benefited from that. But it also takes effort. You have to build partnerships, and that happens again, I say at the grassroots level. That is to say, the researcher at Sandia and Los Alamos, work. We collaborate with them here at UNM. We have joint research activities, and through that we build partnerships and relationships, which then allows us to build the educational programs as well, to give students opportunities to, we have a number of our students who do their PhD research and undergraduates as well at the labs. And that is, I think everyone should sort of think about their local environments and how to build those partnerships.
And then also in the chat, one person mentioned user facilities are a great way to access instrumentation. And our session 3 will be on. You'll have an opportunity to discuss facilities with a large number of user facilities. So it is time to move on to the next session. There is one question that is remaining in the chat from Dr. Height Walker. It would be great, Professor Deutsch, if you could answer her question in the chat.
Absolutely.
As we move on to the next session.
Everybody.
Thank you. Okay, so now I would like to welcome Professor Javier Sanchez Yamagishi from the University of California, Irvine. Professor Sanchez Yamagishi